2.1.1, what do we got? We have determine the value of T91, given the arithmetic sequence 7, 12, 17, plus, plus, plus. Okay, this is a series because we're plussing our terms together. So 2.1.1, determine the value of that. So let's first go and write out our pattern. We know it's arithmetic in nature, which means we have a common difference here. And in this case, the common difference will be 5, positive. Remember, term 3 minus term 2 must be the same as term 2 minus term 1. And we also know it's arithmetic in nature. So if we want to work out the value of a term, we can write out our T of n formula here. I'm going to write it out so that we remember you do get given this on the formula sheet. But you know my rule. If you need a formula sheet before you write this paper, you haven't practiced enough. Okay, 7 plus n minus 1 times 5. Okay, and we can simplify that a little bit if you want to, but I feel like it's extra work. You already got a formula in terms of n and T of n, so I would actually not simplify it out. I would just sub in T91. So everywhere where you see an n, you're going to put 91 and put it straight in your calculator. Don't waste any more time. And the answer the calculator gives us is 457. That is the 91st term of this pattern. The next one is working out your S of 91, so sum of, so 2.1.2, the S of n formula for an arithmetic series, if we do not have the last term, is n over 2, 2a plus n minus 1 times d close square bracket. So therefore, S of 91 is going to equal 91 over 2, 2 times 7, plus 91 minus 1 times 5, close square bracket. Again, use your calculator straight away. And the answer that the calculator gives us is 21,112. Okay, fantastic. 2.1.3, calculate the value of n for which T of n equals 517. Okay, now this is a matter of making 517 our T of n and substituting it into our general rule. So 7 plus n minus 1 times 5. And we're just solving for n here, guys. So that's going to be, take the 7 over, so 510 equals 5, open bracket, n minus 1, divided by 5. That is going to give me 102 equals n minus 1, therefore 103 equals n. Okay, just a lot of algebra. And that is 2.1 finished. Lekker. Let's move on to question 2.2. So let's just extract it here quickly. Okay, there's a total mark allocation of 16 for this. That's awesome. So far, so good. No tricks other than that 1.3. Okay, 2.2. The following information is given about a quadratic number pattern. Okay, quadratic number pattern, very important information, right? We're now dealing with quadratic. That tells us a lot of information. Okay, we need to know our general rule off by heart. They do not give that on the formula sheet. And also how to get the formula for a quadratic number pattern. That is also not on a formula sheet. So, T1 equals 3. T2 minus term 1 is equal to 9. And T3 minus T2 equals 21. 2.2.1, show that T5 equals 111. Okay, so the first thing that I would do, words, not really our friends, guys. So what I would do is I would change this into rather our pattern format. So term 1 is 3. Term 2 we don't know, but we do know that the first difference is 9. And term 3, so we don't know this, and we don't know this. But we do know that the difference between term 3 and term 2 is 21. Okay, so basically what I've done, I've rewritten this in a pyramid format of the pattern, which now tells me a lot of things, because now I know that the difference between this and this is going to be my second common difference. So 21 minus 9 is 12. So let's put the 12 here. Okay, awesome. So we actually have enough information to actually carry on with our pattern, because we know that the difference between this, and if I draw 4, 5, the pattern there, and then that's going to be 12 as well, because it's a second common difference because it's a quadratic number pattern. So that's going to be 21 plus 12, which is 33. And then we know that it's going to be another second common difference of 12, and that's going to be 45. Now you just continue with the pattern. So 3 plus 9 gives you what? And I'm going to do this in a different color. 3 plus 9 is 12. 12 plus 21 is going to give you 33. 33 plus 33 is 66. And 66 plus 45 is 111. Okay. So that is us now proving, therefore, T5 equals 111. Okay, so that is you using your pyramid method to work that out. Now, 2.2.2 says, show that the general term of this quadratic pattern is that. Okay, so we know that the general term for a quadratic number pattern is an squared plus bn plus c. It is a quadratic formula, okay, because it is quadratic in nature. Now, we can obviously use our rules. So we know all we need really from our pattern is these in order to get my formula. So I'm going to write those out. So I'm going to say 3, 9, and 12. Okay. And the rules are, and this is stuff that you need to know off by heart, guys. We need to know that 2a equals our second common difference. We need to know that our first difference is equal to 3a plus b equals that. So that's going to be 3a plus b. And then our last one in our first term is equal to a plus b plus c. And that is a plus b plus c. Okay, good. So now we're going to do our workings out to work out our values of a, b, and c for our general rule. So let's start with 2a equals 12. Therefore, a is equal to 6. The next one is 3. We know what a is now. It's 6 plus b equals 9. Therefore, b is going to equal 9 minus 18, which is minus 9. And then the last one is a plus b plus c equals 3. We know what a is, 6 minus 9, because it's minus, plus c gives me 3. Then we can take that over. So let's do that. So it's going to be c is going to equal 3 plus 9, which is 12, minus 6, which is 6. Okay, and then we can write out our equation. T of n equals 6n squared minus 9n plus 6. And that is what we needed to prove. Fantastic. Okay. And then it says, show that the pattern is increasing for all values of n is an element of natural numbers. Now, the statement where it says n is an element of natural numbers makes sense because patterns don't go into the negative side of values. So your n will always be an element of natural numbers. Now, my favorite way of doing these types of questions is actually graphically. So we know that a quadratic number pattern, what type of graph does that represent? It represents a parabola, right? So, for example, this one specifically, what type of parabola is this representing? Well, this is representing an happy face parabola. How do I know? Because the a value of this parabola function is indeed positive. So what we're going to do here is, in order for us to figure out that, this is what they want us to show, is that the pattern is increasing for all values of natural numbers. Let's figure out where the turning point of this parabola quadratic function is. And we would do that by working out the x value, or in this case, the n value, because it is an equation of t of n in terms of n. The number pattern, or the actual value of the pattern, and the position of the pattern. So if we use our, in this case, n equals minus b over 2a. Does everyone remember that formula? To get the x coordinate of the turning point of a parabola, we're doing the same thing here. So therefore, n is going to equal minus 9 over 2 times 6, which is going to give me 9 over 12, which is going to give me 3 over 4. Now, if I had to graphically graph this, guys, this is what it's going to look like. I know that it's going to have two positive roots. Reason for that is because that's a negative and that's a plus. So that tells me that I will have two positive roots, because if I had to factorize that and work out the x-intercepts, it would give me two positive values. Okay, so I know that it's going to be doing something like this. It's going to be going through 6. It's going to be doing something like that. Okay. Now this over here is our 0, 6, okay? And this over here is now going to be my 3/4, okay? And something. Cool. Now, what I need you guys to remember is that everything to the right of my turning point is going to be increasing. Do you agree? Everything from the right this way, my parabola or my pattern is going to be increasing. So what is the first natural number after 3/4? The first natural number after 3/4 is indeed 1. And everything after that is where my natural numbers are going to be. So have I proven, so they asked for show that the pattern will be increasing for all values of n that is natural. So we have indeed done that. We need to state that n is equal to 3/4. That is when it's going to start to increase. So therefore, n equals 1, right? Because 3/4, you can't have a fraction or a decimal position. It's either first, second, third, or fourth. So your final answer would be you've got a minimum happening at 3/4, and then after that, therefore, t of n. So just to end off this question, we can say, therefore, t of n is increasing for n is an element of natural numbers. Okay, so that is enough working out for you to be able to do it. It's also nice, a little bit more explained to you in a graphical form here. The memos don't really explain that. It's very wordy, but this is a nice representation on why your graph will only be increasing, or your values will only be increasing. The pattern is only increasing after your turning point to the right, because that's what a parabola does. And remember, a quadratic number pattern is indeed a parabola. Okay, great.